element of the Human Lunar Systems National Team. The LEC is also responsible for the development of future systems and vehicles to support human space exploration on the lunar surface, in lunar orbit, and beyond. Prior to joining Lockheed Martin in July 2020, Kirk served as the International Space Station Program Manager. He was responsible for the overall management, development, integration, and operation of the ISS. This nearly $3 billion per year, 15-nation program encompasses the design, manufacture, testing, and delivery of this complex spaceflight hardware and software, and its integration with modules from the international partners into a fully functional, operating, and permanently manned ISS. In addition, Kirk was responsible for policy development, international partner negotiations, and the overall safety and health of the crew and on-orbit vehicle. Previously, Kirk served as the Deputy Director of NASA's Johnson Space Center. In this position, he worked with Johnson Center Director Ellen Ochoa to manage one of NASA's largest installations with nearly 14,000 civil service and contractor employees, including those at White Sands Test Facility in Las Cruces, New Mexico, and an annual budget of approximately $5.1 billion, and helped oversee a broad range of human spaceflight activities. So it's clear to say Kirk has dedicated his career in advancing and improving human spaceflight and has doing it in such a collaborative way. Welcome, Kirk, and thank you today for joining us.
All right, thank you, Kristen, for that introduction. I think what you said is I'm old. I think that's what I heard. But it's a great pleasure to be here. I'm going to try to share some charts. So let me, if you can pipe in, Kristen, let me know you can see them. Can you see them?
Yes, we can see them.
Okay, excellent. So good afternoon, good evening. I can't tell you what a great pleasure it is to be here with all of you today. This is a subject I'm very, very passionate about, the future of human space exploration. As you probably heard, I spent many, many years in my career working on human space exploration. And like I said, I'm passionate about all aspects of it. So I'm glad to have a chance to have this conversation with you. I really do hope it'll be a conversation that we can have. So I wanted to, I spent over 30 years doing all this, done a lot of different things, and I wanted to talk to you what I believe the future will hold. But before we get there, I really wanted to kind of start with the past. What really got us here, or what really got me here. So I can tell you it was a warm, muggy, very humid Sunday night really, in a small coastal town in South Texas in the United States. My older brother and I were both in bed, but we couldn't go to sleep. It seemed like the house was just full of excitement, and we could hear it even in our bedroom. After a while, my father came into our bedroom and said, "Hey, get up, come into the family room. You're going to see something amazing." And a few minutes later, staring at a black and white TV, we see Neil Armstrong bound down to the surface of the moon and make the first human footprints on that neighboring celestial body. What an amazing thing it was to see. Frankly, what an amazing thing to be part of, even as a young boy watching it. So a few minutes after we watched it on TV, we walked outside. My dad took us outside. We went up and we squinted and looked at the moon. And I swear I can remember very distinctly trying to see Neil Armstrong in that spacecraft from my front yard. Of course, as you know, that day was July 20th, 1969, and I was 6 years old at the time. I could still remember it very, very clearly, like it was yesterday. And that really, that night has led me here. It really fostered in me a great love of space flight, of flight in general, and that's why I'm here today. And I wanted to share my thoughts here with you. So this is what it looked like when I was watching TV. So today, I know most of you have a picture of what it's like to sit at home and watch TV. But back in those days, most houses didn't have a TV at all. And if you had one, it looked very much like the one here in this picture. and ours certainly did. It was black and white, and this is probably what you think it looked like watching it on TV. This is actually a moon a photograph taken on that flight. If you look and you can see these little X's here on the screen, that's how you can tell it's a real flight. But actually, this picture was taken with a camera that had film in it. The film was brought home, developed, and here 51 years later, I'm beaming it around the world today in much greater clarity than I can tell you we saw it back in those days. So here's what it really looked like. If you want to know what it looked like, this is what it looked like to us. Now, I don't know about you, this is terrible by today's standards. You wouldn't watch anything on TV that looked like that. But for those days, it was a miracle to be able to see that, to actually live those first steps. So I was really, really excited to have seen that, to have been part of it. And like I said, I think that's why I'm here today. That's why I'm here speaking to you. Why I spent over 35 years of my life pursuing human spaceflight. So why do humans explore? Why do we go out and we look around and we want to go out further and further into space? I don't know really why all those reasons are. So I thought to myself, where would I go find that? So I went to the source of all human knowledge. I went to Wikipedia, and it said to explore is to conduct a systematic search or travel over a new territory for adventure and discovery. So John F. Kennedy, who was the president of the United States at the time, in 1962 at Rice University, which is there in Houston, Texas, kind of expressed one reason to go to the moon or to go explore. He said, we choose to go to the moon. We choose to go to the moon this decade and to do the other things, not because they're easy, but because they are hard, because the goal will serve to organize and measure the best of our energies and skills. And because the challenge is one that we are willing to accept and one we are unwilling to postpone. So that's certainly one reason to go explore, and a reason that we have done so in the past. So there are many other reasons we go explore. So scientific discovery is one. The picture that you're seeing here is a picture of an experiment run at the coldest place in the universe. It's an experiment called the Cold Atom Laboratory, which is flying on the International Space Station. And it's imagery of a Bose-Einstein condensate as it persisted over time. And actually they can be colder and persist longer in microgravity than they can here on the planet. So it's, anyway, it's ironic. The coldest place in the planet is not really on the planet. It's up in space. Another reason we explore is human curiosity. We strive to drive, technology. So many governments invest because, hey, if we can do this, we can drive our technology. We can be more competitive in the world marketplace. Another reason people explore is resource exploration. So doing things like shown in this picture, people have ideas of mining asteroids, or maybe they're interested in doing both scientific discovery and mining asteroids. So here's a picture just taken a couple of weeks ago of OSIRIS-REx actually landing and mining, if you will, a small sample from Bennu, the asteroid. So it was a spacecraft, I'm happy to say, was built here, built by Lockheed Martin and operated by Lockheed Martin. And I think that the activities to date have been fantastic, and we're really looking forward to getting that sample home. Some people explore, or some entities explore to create a brand name. So what do I mean by that? So actually, here's a perfect example of space agencies. I've had the very great pleasure to travel around the world in my career. And I can tell you, I've been to some very, very remote places in countries that really don't have anything to do with space. And it's amazing to me to go to these small places and tell people they ask me, well, where do you come from? What do you do? I say, I come from Texas and I work for NASA, and they all know it. And so the brand recognition from going into space is huge. While I work for NASA, or did work for NASA at the time, I know the same experience holds true for other space agencies. In fact, if you watch any payload picture from space, you'll see brand names of companies in there. So it really is important to create a brand name, and that's why a lot of people, countries, and even companies explore. So another reason is we want to create a multiplanetary species. It's very clear that having additional resources, having other places for our species to grow and flourish is really, really important. And there's a number of entities out there that are aligned behind that particular thrust. I think space exploration in general leads itself to having us be a multiplanetary species. I do expect that to be our future, but that's a reason. Another reason, and a big one for me personally, is to inspire future generations. So when I was little, textbooks basically had, at best, a photo from a telescope on the planet. And today we have spacecraft that have gone and visited those planets. This is one of my favorites. I call this a selfie. This was taken by the Cassini spacecraft, and you can detect the Saturn's rings there in the foreground. But the little dots are actually the two little dots you see is Earth and the Moon. So this one's one of my favorites because it makes me realize how small in the scheme of things, and actually just in the scheme of things of our solar system, we are. So today, inspiring the youth has been a big factor. It's inspired some over 180,000 workers in the United States to work in the space industry, and so that's really important. Why do we explore multinationally? So why do we go and explore besides just with the with each individual country? Well, one of those big reasons, I believe, is because space has no borders. So when you look at the Earth, this is an actual photograph taken from the International Space Station. You see all this beautiful land, you see the water, you see the clouds. Actually, what you really see is the very, very thin nature of our atmosphere, the thing we live on, we would count on for survival, and yet you don't see country borders. So it's just natural that space we would do as a multinational endeavor. By the way, when one looks at the Moon and Mars, you also don't see any borders. Of course, you can bring more resources together as you work together than any one country could bring. So, and you probably have heard NASA has published, or the United States published, Artemis Accords, really seeking to bring other countries into an endeavor here to go explore the Moon. We'll talk more about that in a few minutes. The International Space Station is a great example too of bringing more resources to bear than any one country could do on its own. And I bring this up for a couple of reasons. One, I think it is a great example of that. Number two is here just a few days ago, on November 2nd, we celebrated the 20th anniversary of permanent human habitation on board the International Space Station. So for the last 2 decades, people have lived and worked off the planet. The first crew, Bill Shepard, who was the commander, Sergei Krikalev, and Yuri Gudzinko, first came aboard the International Space Station that morning on November 2nd, and really have set the tone, set the standard, really set the expectation of the world for humans living and working off the planet. International relations, I believe, is another big reason. It brings countries together. If you can have a kernel of peaceful cooperation, you can grow to have a much more peaceful, beneficial relationship between countries. And I can tell you I've experienced that personally over my career. You also get a diversity of ideas. People with different backgrounds, different education, different cultures can bring new ideas to bear, new ways of doing things, maybe even new problems to attack. So that diversity of ideas, diversity of background, diversity of thought really makes it more successful if one does it internationally. And finally, I'll mention one I believe in strongly is political inertia. So countries have a much harder time walking away from an endeavor, especially an expensive endeavor like human spaceflight, if they're in it with allies. On June 24th, 1993, the International Space Station came within one vote of being canceled in the United States. I firmly believe at that time, of course this is well before the first piece flew into space, that it was the fact that we had this treaty basically with the other nations supporting the International Space Station that caused us to hang in there and build this magnificent laboratory that we've had on board up in space and been operating for 22 years and had humans on board for 20 years. So where is human spaceflight going? Where do I think human spaceflight is going? Well, first we're going forward to the moon. United States Space Policy Directive number 1, which was just signed not too long ago by Vice President Mike Pence and President Donald Trump, directed NASA to lead an innovative and sustainable program exploration with commercial and international partners to enable human expansion across the solar system and to bring back to Earth new knowledge and opportunities. Bring with missions beyond low Earth orbit, the United States will lead the return of humans to the moon for the long term, for long-term exploration and utilization, followed by human missions to Mars and other destinations. We plan to put the first woman and the next man on the moon by 2024. So what are we doing? Of course, today I work for Lockheed Martin, and we're part of the national team who's competing for the opportunity to build the lunar lander that takes the first woman and next man to this planet. And so I just wanted to say that that's what we're working on right now, and making great progress. So the Blue Origin's the national team is led by Blue Origin. Of course, Lockheed Martin is part of it, Northrop Grumman, and Draper Laboratories. So we're very much looking forward to having a successful flight to the moon and back by the end of 2024. So once we get there, what are we going to do? Actually, there's a tremendous amount of activities, both scientific and commercial, that will occur on the lunar surface. This chart has a lot of things on it, and I can tell you there's lots and lots of different ideas of what one can do on the moon. You can see observatories, rovers to explore, communication satellites, exploitation of resources, basically habitats for humans to live and explore and conduct those activities. Tremendous amount of opportunity there on the lunar surface when we're there sustainably to stay. So what are we doing after that? Well, of course, as you heard, the idea is to take what we've learned in low Earth orbit aboard the International Space Station, what we learned on the lunar surface, and go forward to Mars. So here you have a spacecraft that could take humans to Mars, and orbit Mars or pass around Mars and come back. And of course, ultimately, we plan to have humans land on Mars. And I really do hope to be present and hopefully to be part of putting a human for the first time on the surface of Mars. So what are the key technologies that one has to have in order to do this? So NASA has put together a list of 17 key areas for technology, but let me just list a few that I hold near and dear. One of the biggest issues that we have right now is cost of transportation, both cargo and people from the Earth to low Earth orbit. That cost, the cost of operating the International Space Station, almost 50% of that cost is taking cargo and people to and from the International Space Station. So having more efficient transportation is really, really important, both from the surface of the Earth to low Earth orbit, but ultimately to have more efficient propulsion and transportation once we're in space. So we can do that with higher specific thrust, basically more efficient engines. We already have the technology for engines that have 10 times the efficiency of the high thrust engines that we have to fly humans from the surface. However, those high, really efficient engines have very, very low thrust, and they're not really compatible with the time frame that it takes to try to take humans from one planet to another. For instance, to go to Mars, the fastest trajectory to get to Mars today with chemical propulsion, with the fast propulsions we have, is about 6 months. And by the way, when you come home from that trajectory, it's about 18 months to make it. You can imagine, and that's using high thrust engines. If you were using a thrust of only a few newtons, it could take years to get to Mars. So today we have ion thrusters, Hall effect thrusters. We're working actively on nuclear propulsion. All those things I think are key technologies. Power generation and storage. We need more efficient solar arrays. We need fission power. And boy, the world would be such a better place, as would space, if we could come up with fusion power. So habitation, we need more room for people and cargo. Of course, those people in cargo now on the surface of the moon and ultimately on other planetary bodies need protection from hazardous radiation. So we need ways to protect those humans from radiation. Autonomy is a big issue, even when you're on the surface of the moon, but certainly when you go out to Mars, where you have minutes, many minutes, 20 minutes of time delay just for speed of light delay. We have to be able to, the crew would have to be able to monitor, they'd have to be able to have medical technology, operate a complex vehicle, make repairs, all those things, more knowledge than any one human could cram into their brain. They would have to have that capability. And then, of course, we'd want to operate the vehicles when humans are not present. And so autonomy is really a key technology area. Finally, we want to have reliable life support systems. Actually, our lives depend on it. So today we have life support systems, but I'll tell you, they are all have failures, certainly failures in the time frame that don't support flights on the time frame to go to Mars. So we need much more reliable life support systems. And ultimately, one of the most difficult things with life support systems is to handle periods with humans and then no humans. And that period of dormancy can actually be very, very difficult on that equipment as well. And again, once humans come back, your life depends on it. Policies. So what policies do we need? So I can tell you a few. There's probably many, many more that some of you delegates understand what they are. But let me tell you some that I think are really important. Liability. Today, there's all kinds of liability that people look at. Obviously, launch liability. They worry about on-orbit re-entry of vehicles. Of course, collision of vehicles when they're in space. All those things cause a liability concern, and the cost of insurance is crazy. And it's very, very sensitive to any given failure. So having some policies, some strategy to manage that liability, make it affordable for all the spacefaring nations and spacefaring companies, huge. Commercial enabling legislation or policies. Transitioning from space as being a domain purely of governments to a domain that's, I believe, for low Earth orbit, we commercially dominated. We need international consistency with policies. Today, there's an international union, the ITU union that handles licensing, but I can tell you not every country recognizes that. So in some cases, a satellite wants to launch to the United States, it doesn't have its license, it can't launch here, but it just goes somewhere else to fly. I'm sure the case exists in other countries as well. Space debris, a huge area that we have to watch, we have to manage, and because the consequence of space debris, because it stays in orbit for many, many years, maybe many, many decades, maybe many centuries, depending upon where it is. We can't allow space debris to be created and certainly proliferated. Traffic management, very similar to that. The number of satellites that are going on orbit is growing exponentially. And making sure that we don't end up with two satellites at the same place at the same time is critical. And we can't rely on the big space theory anymore. We already have examples of satellites colliding. And when they collide, they create thousands of pieces of debris, which will be up there for decades to come, creating hazards for humans and for commercial companies and countries. Huge issue. Light pollution is one that's coming up. We're already seeing satellites are causing difficulty for astronomy here on the planet. Finally, I'll mention planetary protection. One of those issues of planetary protection, of course, is leaving objects, debris, if you will, spent objects on other planetary bodies. Perhaps one of the ones that we're going to face very, very soon and much more often is actually bringing objects back to the Earth. So we're retrieving objects from other celestial bodies, bringing them back to the Earth. What hazard does that bring to the population of the Earth? Again, it's an international policy issue. And finally, land use or capital use on other planets. So we talked already, asteroid mining and other resource utilization. That day is coming where countries and companies are going to want to do that. We need a framework where we can do all those. So just wanted to wrap up by a few thoughts. First, it's clear that it takes all of us, different companies, different nationalities, different expertises, different ideas to realize the future of human spaceflight. I want to leave you with this. This photo was taken from Apollo 17, from the command module. That flight was launched from Florida on December 7th, 1972. It actually departed the lunar surface on December 14th, 1972. So coming up on 48 years ago. Of course, it splashed down. The crew was successful in flying and executing that mission. Ron Evans, who was the command module pilot, Jack Schmitt and Gene Cernan went on down to the surface of the moon. Gene Cernan was the last person to step on the moon. Was the last footprint left by a human being on the moon was from Gene Cernan. And when he stepped off the moon, or as he was stepping off the moon, he uttered these words, and I wanted to share them with you because it's my hope for humans, human spaceflight, and for humans going back to the moon. So Gene said, "I'm on the surface, and then I take man's last step from the surface for some time to come, but not too long, I hope, into the future. I'd just like to say what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon, Taurus Litro, today, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed for the crew of Apollo 17. And I believe and I hope Godspeed for all of us." Well, with that, I think what I'd like to do is stop here, and maybe you guys have some questions. I'd be happy to answer anything I can.
Absolutely, Kirk. Thank you for that talk. It was wonderful. So right now, our top question is, what was the toughest challenge with integrating humans on the ISS to live there permanently rather than for various missions? Hi there, Kirk. We can't seem to hear you. Is there
How
any?
about this? Can you hear me now?
There it is. All right, sorry.
Oh, awesome, good. So what I was saying was humans, it was integrating the humans into that is probably the hardest thing. What we found, of course, is humans, one is they take a lot of, they actually are not very robust in the scheme of things. They take a lot of care and feeding in order to survive. And they're really hard on equipment. So we found that actually keeping the humans alive and the equipment that's required to keep them alive is really, really difficult. We learned a tremendous amount, lots of great war stories I could share with you about this, but things that we knew about humans and we tested on the ground and we went up in space. It turns out humans adapt differently. Their bodies change when they're in space. It makes it really, really difficult. And of course, there's a psychological changes. And then of course you have multiple humans living together in a very, very small volume. That creates dynamics. So that's probably the most challenging. Plus, as an engineer, I can figure out physics. I have a hard time figuring out humans. So for me, that was the biggest challenge.
Right. So our next question is, what are some of the biggest mysteries we still need to understand about the moon? How do we create scientific and commercial lunar missions to address these challenges, make new discoveries, and advance commercial lunar exploration and settlement?
Yeah, so what are the biggest questions? I have to say I'm not a planetary scientist, so I'm going to tell you what I understand. So obviously water on the moon, and you guys have all heard that. Hell, we just had an announcement here 2 weeks ago, I think, of additional water discovered. Huge benefit. One is if humans are going to live there, if you have water, you can electrolyze it with using energy from the sun, and you can you make it easier to keep the humans alive. Of course, you can manufacture rocket propellant, and leaving a rocket full from the moon is much easier than from the Earth because of the 1/6 the gravity. There's a really interesting basin on the South Pole area of the moon, the Aiken Basin, South Polar Aiken Basin, which planetary scientists believe is a great place to go look at records there. You can see it's very clear, and you can see some impacts there. And they believe that a key understanding of how the moon evolved and perhaps how the Earth evolved or formed in the earlier solar system days can be uncovered from information there. Of course, there's other things. We talk about the dark side of the moon, or at least I do, but frankly, it's not dark. It just happens to face away from the planet. But if you could put radio astronomies there, radio telescopes there, you're in the shadow of the Earth's magnetic emissions. So you can actually learn things today because we have great technology that we can glean that we really have a hard time on the planet because of all the RF interference that we have. So it's a great opportunity for there. I also believe the greatest discoveries are yet to come. So those are the few I know about, but I think there are many, many more. And I think we'll, as we go there and learn more, we'll actually, my experience has been as we learn and answer a few questions, what it does is open up 10 questions for every one that we answer. And I believe that'll be true here. And commercial, gosh, the commercial guys come up with ideas to make money that I couldn't even dream of. So that's the other thing I've learned is if I could think of 5 ways that we could make money, I'm sure there's 5,000 ways that we can make money. I'm really looking forward to the space economy evolving from not only a robust low Earth economy, but ultimately expanding to the moon.
Absolutely. It's really exciting right now. So our next question is, what has been the biggest technical challenge you've encountered on the ascent element for HLS? How has Lockheed tackled that challenge? And what do you think was or will be the most important part of the solution?
Wow, those are great questions. And I'm going to punt. I would love to talk to you about that, and I'd be happy to. It turns out we're in a competition right now, and the competition doesn't end. We submit our proposals in early December, and then a selection's made in March. So if I have an opportunity to talk to you after March, I'll be happy to share all our secrets. But right now, unfortunately, I'd rather not talk about that, other than to say I'm really excited. It's a great technology, technologically, programmatically challenging task, and I left a great program on the International Space Station working for NASA to work on an even more challenging program, which is this lander. Come work with us. That's what I'd say. Come work with us, and I'll tell you everything.
Great. So our next question is, what is your company doing to address the concern of orbital debris creation in low Earth orbit?
Okay, well, that's a great question too, and I wish I knew. I don't know if you heard from my bio. I've been here 3 months. I started in early July, and so I'm sure they are. I have no idea what it is because it's a huge problem for everyone. It is a huge problem for Lockheed Martin. It's a huge problem for the United States. Frankly, it's a huge problem for every country. It's a huge problem for people who don't even realize it's their problem. All these things we take for granted today, when you get in your car and you want to know where you go, or you pull out your phone and you use Google Maps and you can see where you're going and your little blue dot moves around. Well, your little blue dot is subject to space debris. So everything we do almost on a daily basis that you take for granted is at danger because of space debris, and it's the problem we have to solve. So the first thing I can tell you for sure we are doing is when we build spacecraft, we build it with the mindset of not generating additional space debris. We certainly try to dispose of our assets as they've reached the end of their life in a way that doesn't create debris. But frankly, we need to have a way, ultimately we as a species need to have a way to go eradicate the debris that's up there or that's likely to be created as we go forward. And that's the part I don't really know. Big problem though. If you want a big hairy problem to go solve, that's the one. That's a really important one to solve.
Mm-hmm. Absolutely. So our next question is, I loved watching your story of Neil Armstrong on the moon, inspiring you to get involved in space exploration. So what goes through your head when you see the space station flying overhead, having played such a crucial role in the ISS program?
You know, I still go outside and watch it. You can go to spot the station, by the way, no matter where you are in the world. You go to just type in spot the station and the website will come up. You can find your spot and see when it's coming over, when you can view it. I try to go outside and see it. It's awesome because you see this dot. It's very, very silent. If you're not looking up, you won't see it. You certainly won't hear it. But it's bright. It can be the brightest object other than the moon and the sun, obviously. It can be the third brightest object in our sky. It can be brighter than Venus when it flies by. And the thing that it's this little dot that moves rapidly across the sky. And the first thought is there's people up there, and frankly, I think of them as my friends. You know, almost everyone who's flown aboard the space station in the last 20 years, whether they're, regardless of what country they're from, are friends of mine. And the second thing is the scale of it is huge. The size of it is about the size of a football field or a soccer field, if you will. It's 100 yards long and 50 yards wide, you know, and it's traveling as fast. It's 17,500 miles an hour. And the scale of it is just magnificent. So it's just a wonder, even, you know, having been apart from the very beginning to just a few months ago, it's still a marvel to me. I wish, I tell you, I had a part in it, but so did thousands and thousands of other people. And my part was no bigger than anyone else, but I really am proud to have been part of that. Help create that wonderful vehicle, hopefully that wonderful discovery outpost for humans for decades to come.
Okay, so our next question is, given that launching to orbit is so expensive, how do you expect the field of space resources to be changed in the near future? Do you expect that an economy will actually be started for space-based materials? And if so, how long do you expect that to take?
I can tell you that companies are working on it right now. And I can tell you that companies are working on things, and I have seen the business cases, and they actually close. So the deal is they have to manufacture these things that they're going to manufacture, and they have to be able to manufacture them with the quality that they say they're going to do it. It turns out that's not a trivial thing, but once they work out the manufacturing details, they know it can be done. They just don't know exactly how to do it. Once they do, I think there are some things that already the economics close. I think there's an economy of scales as you do more of these kinds of things and you create a more traffic pattern. Actually, some of the cost goes down. You know, if you design and build a rocket, it costs you have to recover the entire cost it took you to design that rocket. But if you're flying many flights, the fact that you designed it, that the cost of that design actually gets spread out over all those flights. So it actually becomes cheaper and cheaper. Of course, you can learn to manufacture them quicker, and then reuse itself is another area which will drive the cost down. So I believe that additive manufacturing has the potential to drive costs down. I think you'll see, which means the types of things you can manufacture, the spectrum gets broader and broader. I think that's what our future is. The economies are going to, the price is going to be driven down for the transportation, and the things that we can build in space and can't build on the planet is going to go up.
Yeah, absolutely. So our next question is starts out with, thank you for such a great presentation. What are your thoughts on the future of the International Space Station? Well,
I'm pretty sure it's going to go around the Earth 16 times a day, today and tomorrow. That's so people ask me about that a lot. In fact, even while I was program manager, that was a big discussion. Technologically, or let's say it's a machine, right? It is a machine. It has a finite life. ISS will one day be a reef in the Pacific Ocean, I have no doubt. But when is that date? And I can tell you, as a machine, it has life, I believe, well into the 2030s, perhaps beyond that. So that's going. I don't think the end of life for ISS is going to be the fact that it's no longer safe for humans to inhabit it. It takes the political will of all the partnerships. NASA, Canadian Space Agency, European Space Agency, Russian Space Agency, Japanese Space Agency. It takes the political will of those agencies and those countries that support it to keep it going. So as long as that political will stays there, and frankly, as long as it's productive, as long as there's new discoveries, there's new commercial activities, all those things that it was built for, as long as those are gone and productive, I believe the countries will support it and it'll keep going. My personal hope is it'll stay up there until there's commercial platforms up there that could take its place. I think those commercial platforms will be much smaller initially. So I hope it can stand, and I believe that'll be at least 2030. I'm sorry, yeah, at least 2030. So I hope it'll be around till then, and until these commercial platforms are up there. Once the commercial platforms up there, I think it'll be unfair advantage, the government competing with a commercial company, and the government always wins. So at that point, it'll be time for it to come home. If it comes home before commercial platforms up there, or before we're routinely flying humans to the moon, frankly, I worry that we as a species, we as the planet, will take a hiatus from human spaceflight, and I really don't want that to happen.
Right, of course. So our next question is, after we reach the moon again and then onto Mars with a sustainable presence, what then do you think or hope that humanity's next greatest accomplishment may be, and how do you think we could reach it?
You know, Europa is a very intriguing thing for me personally. I think there's the potential for life on Europa. NASA's planning a mission now to go and take take readings, if you will, samples, not to return them, but to take them. So after we go to Mars, I think Europa. Right now, today, what I would say is Europa is probably the next logical place. It's going to be exponentially harder than going to Mars, and as you know, as most of you know, going to Mars is exponentially harder than going to the moon, and going to the moon is exponentially harder than going to low Earth orbit. So it's a hard, very, very difficult thing to do, but I think we'll do it. I think that'll be the next place that we'll go. The other possibility, anyway, is there might be some interesting asteroids to go to. So we might discover something as our astronomy, as our telescopes, as our instruments to read and detect and discover things about asteroids. We might end up going to an asteroid before we go to the outer planets, but we'll see. I hope I'm alive to see it.
So our next question, you mentioned that advanced power and propulsion systems are particularly important for sending human crew to Mars. What do you see as the most promising developments in this area? Where could NASA, other national agencies, and private enterprises invest for technology development?
Yeah, so propulsion, high efficiency. So again, the reason why is it so much harder to go to Mars than it is to go to the moon? And the answer is everything you're taking with you, everything that you need to come home, you have to take with you, and you have to accelerate it out to Mars, stop it there, and then bring it back. Number one, which means it's tremendous. For every kilogram you're taking, and I forget the gear ratio, I think it's like 20 to 1. You have to take 20 kilos for it. So it gets to be crazy. If you had to carry chemical propellant, the best you can do, the most efficient you're going to get is if you use liquid oxygen, liquid hydrogen, you're about 450, 460 seconds. But you can get 3,000 seconds. You can get almost an order of magnitude with electric propulsion. And so that's important. That's why it's so important. You can adjust that gear ratio so you don't have to take so many kilograms with you if you can do it with much more efficient engines. I think nuclear power or nuclear propulsion is important because if you're going away from the sun, solar starts dropping off crazy. And in fact, you can do solar power on the Martian surface. We've shown that. But frankly, if you go much farther than Mars, you're going to have trouble. So I think you ultimately need nuclear propulsion for power, nuclear power for anyway. And if you're going to do that, why not use it for propulsion as well? So I think that's the wave if we're going further and further away. If you're going to go to Venus, your solar rays get better. So maybe you don't need it. Although once you get on that cloudy surface, you're probably going to need something. Your solar rays aren't going to work much there. But anyway, I think that's the that's probably the key for those. That's why I think it's so important. I know NASA is investing in it now. I think they will continue. By the way, anything that has the word nuclear in it ends up being not just NASA, but Department of Energy in the United States. I'm sure other countries do it too, do things differently. But I think if you're interested in that, look at what DOE and what NASA are putting out. And then of course there's the DARPA is also an area that's looking in those areas. So if you just Google that and see what technologies they're working on, I think I think they have it right. I think they're looking in the right directions.
Very exciting, that's for sure. So our next question from YouTube, actually. You have focused on managing the ISS over your career. Was it challenging or natural to transition from managing the Lunar Exploration Campaign?
Wow, that'd be a great question to ask in a year. It's extremely challenging to go from where I was to here. I started working on the International Space Station in 1994, but way before, 4 years before the first element was launched. So I knew the program, I knew technically how the station worked, knew all the systems, knew the people, knew the international partners. And so now I'm moving to a company of which is a large company, but I know 10 people at the company when I start. I know nothing about the lander, the design that they already had. So yeah, it's a huge challenge. It's a huge challenge just understanding how the company works, understanding our design and the difficulties and the issues associated with that, and with flying to the moon, flying to the surface of the moon by itself. So a huge challenge, but that's what makes it so exciting. Gosh, if it wasn't challenging, what would be the point? So personally, I that's why I did it. I wanted to, I think we're not talking about careers here, but if you were, I'd say, hey, in a big position like the program manager for the space station, somewhere between 5 and 7 years is the max you should stay there anyway. It's bad for the organization, probably bad for you personally to do it. I needed to leave. The station program needed me to leave, and I wanted a big challenge, and this is absolutely a big challenge. It's very exciting though. I get excited about coming to work every day, and I'm thinking about it all the time. So it's great. I'm glad I did it. But if you really want to know the full story, give me another few months, and then I'll tell you what it's really like.
Of course. So our next question is, which roles should governments, advocacy policy consortiums, and commercial companies own in moving to an off-Earth permanent residence?
Wow, that's a lot. I think so. There's this whole notion of where there really isn't any economy. There's no commercial drive to go there. But we as a species want to go there. That's got to be the domain of the government. When you talk about commercial entities wanting to go there, and clearly communication satellites, we've been there for years. Low Earth orbit going commercially is just now in its infancy. I think that's where policy becomes important, but governments and agencies need to back off. So, but that policy vacuum is really, really significant. Bad things can happen in this area where we don't have good policies. So again, think of small satellites. I'll call them CubeSats, but I mean not just what is actually a CubeSat, but even larger. There's thousands of them being launched every year now. Thousands of them. They're all going up there. It's like very, very unregulated, I would say. They're launching these things, and what's the protection to keep them from colliding with one another? By the way, who's watching to see all these different companies and frankly countries launching these things and making sure they don't interfere even before they launch them? Because once they're launched, it's the die is cast, right? They're put into orbit, and they have limited, if any, ability to change their orbit. So this is where policy, I think, and governments are going to have to get together to create these international policies, this international framework to go work. And if they don't, it's not only is it bad for companies, it's going to be bad for countries. So that's really, really important. But it's hard to get started because You know, a given country will say, let's do whatever we want. Our companies can make a bunch of money. And that's true right up to the point it becomes hazardous and no one can even tolerate that environment anymore. So it really takes forward thinking. It's going to take a lot of convincing for people to go convince their governments to go do this. But that's what's necessary, I think, ultimately for us all to be successful in the long term.
Absolutely.
By the way, I'm speaking as an individual here, not as I'm not telling you a company policy or a country's policy. I'm just giving you my personal thoughts on that.
Of course. So we have time for just a few more questions. Everyone feel free to upvote any last ones you want to get answered. But our next one we'll ask is, as you know from your experience at NASA, the direction of human spaceflight can change frequently based on the US Executive Office, Congress, funding allocation. Since switching to the commercial space industry, do you anticipate the future of commercial human space exploration to be more stable and less dependent on NASA missions?
I think it will be more stable as we go forward. Yes, there's I don't know. I'm trying to think of the right terminology to use, but there's a certain amount of energy that an energy threshold that you have to overcome. And I believe the commercial industry relative to low Earth orbit is just at the point of overcoming that, and in which case I think it'll be much more stable. As you're climbing up that energy curve, as administrations change and thrusts of large government programs change, it can actually cause you to drift back down that curve. But I believe once at some point in time there's enough commercial activity that's going to go on regardless of what the government programs are doing. And I believe we're close to that point. We'll see if we are. My hope is that we won't see drastic changes. Someone was asking me, there's a big election in the United States, for those of you who don't live in the United States, and people are saying, well, is it better if candidate A wins or candidate B wins? And I said, well, the worst thing is the uncertainty. The worst thing is uncertainty. So the same thing is true here. I think having a policy about government programs and having some stability to them, some certainty of them, is most key. Where specifically what they are is not as important for commercial entities to survive and thrive. So my hope is for stability. That's what I hope.
Yes. So we're going to end on a fun last question. So taking into consideration the multitude of successful missions and multinational activities on the ISS, do you think the ISS should be awarded the Nobel Peace Prize?
Well, I'm a biased person. I was very much a proponent. ISS has been nominated several times actually for the Nobel Peace Prize, and I absolutely think so. I think it has brought the world closer together. Not only the countries, the agencies that are involved, but over 107 countries around the world. 107 have been involved in the International Space Station in some form, whether it's running an experiment, obviously being a part of it, contributing to it. So it really has brought the world close together. Countries that are working together and understand each other are much more likely to deal with each other peacefully. So absolutely, I think it should be. And for what it's worth, I would appreciate all of you supporting that effort.
Absolutely. I think a lot of us are on board with that. Well, Kirk, thank you so much for joining us today. It was a real pleasure to have you. We learned a lot. So thank you so much.
Thank you. It's been a lot of fun. I wish you all the best and have a